Hey classes, welcome to the 2021-2022 year in science here at IBL. If you look at the board behind me and the things that are on it, we're going to go through what a typical day looks like here in the science class. You'll notice the board behind me have the handwritten notes on there. I like doing the handwritten notes on the board in combination with a little bit of the PowerPoints because pretty much it keeps me on track with how much the students should be writing in class. I don't want to overdo it on the writing. Don't want to underdo it either by doing the notes, and I pledge always to do the same amount of the work that the students do. When I assign something, I do the assignment as well. Again, it's designed to make sure that the students are doing kind of just the right amount, that kind of sweet spot of making sure that we're doing labs and we're doing our notes and we're keeping up, but it's not too much or too little, getting you ready for 8th grade and beyond. So jumping right in, the current events. On the current events, I usually start with the current events. I did use CNN 10 today. However, I'm kind of changing that up a little bit because I know some other teachers use it. There might be a little bit of overlap. I used to think I was so cleverly using CNN 10, but it's become more and more popular. I do love using some current events from science, and one of the things that they talked about today on CNN 10, and again, I only use the things that we talk about throughout the year here in science. One of the things they talked about here is the Boston Dynamics robot. Great to look up for yourself if you get a chance to see that. On Boston Dynamics, they've got these amazing robots. That was one of our notes, one of our things I wanted to point out because, over about the last 20 years of my science teaching, the standards haven't really changed that much. Certainly they've changed names and they've changed their focus a little bit. The one thing that has changed, I would say, in the 7th, 8th grade and high school standards in science are a little bit more of a focus on engineering, and certainly the Boston Dynamic robots are a good example of that. The International Space Station, a little bit on that was in CNN 10 today, and we talk about the forces, especially Newton's laws. Later on in the year when we go through Newton's laws, we do quite a bit on things that are in orbit. ISS was a good example of that. And then finally, what was the other one? The hurricane. Back east, there's a hurricane blowing up the eastern seaboard, which is very, very unusual. Now it's a tropical storm. If you look at the warm water that's in the Atlantic, things have been changing in terms of the climate. Our oceans have been heating up, mainly because we've been putting a little bit of gases in the atmosphere, more than a little bit, that are trapping some of the solar radiation. Definitely a big topic over the course of the school year, how our environment is changing, and understanding that is critical, understanding life on this planet. Moving on from there, we have, being a Monday, our 10 key terms. Now these 10 key terms, usually it's about 10 key terms per week, carry us through the week. These are the things upon which we focus that week, which brings me to the science notebook. When we do our key terms in our science notebooks, in other words, when we define our key terms, our notebook is, without a doubt, the most important part of this science class. This notebook helps us not only keep our information in one place, but it is a reference that we can go back to throughout the year. It's important to notice that we have this notebook because it's a cumulative thing. For example, all the way in week 20 or 25, we might refer back to things in week 2 or 3. So it's really important to keep a good notebook. That being said, one of the places where we keep our videos is at a blog, pacificascience.org. I'll link that down below in the description, and also I'll send that out to everyone through Google Classroom and Jupyter Ed and Synergy. And that's a really important place to make sure that you're keeping up with the notes. From there, we talked a little bit in class today about a Richard Feynman quote from last week. Always trying to profile a few scientists, one of my very favorites. He talks about how experiments are really at the heart of science. Again, I was trying to make the point with the students today. I'll make the point hopefully throughout the year. I'm going to reach over here and grab one of the textbooks that we use. But if you check out the textbook here, with of course a mask on it, the textbooks are a wonderful resource. A lot of great information here. If you read and remember everything that's in the textbook, great, but that's not really science. Science is about a process. One of Richard Feynman's quotes went along the lines of, you can have the greatest theories, the greatest ideas of the world, but if it doesn't stand up to experiment, it's wrong. That is really what I'm trying to get across over the course of our 9 months together, that science is really about a process of discovery, a process of trying out things and seeing if your ideas, if a hypothesis holds up. So over the course of the 9 months together, as a matter of fact, today we started our first little data gathering on checking out if a prediction can be made based on the amount of information that we collected in class. For our information today, well, I get the whiteboards lined up here. The information that we gathered today happened to be on, can you predict a person's height in centimeters, standing up, based on a person's, what the book calls wingspan, what the book's often called wingspan, but really it's just the distance from one finger stretched out this way, one hand stretched out this way to the other. In other words, pardon me, can you make an accurate prediction of one variable or one quantity based upon another? That being said, the other day, when I say the other day, Thursday and Friday in the previous class, we talked a little tiny bit about a Mythbusters episode, picked selected parts of it, where they were kicking two different footballs. One football had helium in it, the other football had regular air in it. And the Mythbusters in this episode, we used about, maybe 15 minutes from the episode, did a fantastic job of controlling the variables when they're kicking the football. At first, they had a gentleman from San Francisco City College kicking the footballs. They quickly realized, as good as this kicker was, a person cannot possibly reproduce the exact same kick or shot again and again and again. So they started controlling things like the weather variable. They brought him indoors. They brought the test indoors. The kicking variable, they actually got a kicking machine, or in their case, a throwing machine. They wanted to control the PSI, the pounds per square inch of air in each football. And if you check out the board behind me, there's a couple of other things that they controlled for. And in any good experiment, we're trying to control all the things that might influence our results so that we can isolate the one independent variable that we want to test. That was really the theme as we begin our week 1 and 2 experiments. A couple of things I just wanted to point out very, very quickly was the math tie-ins. Whatever your math teacher is across the hall, you probably have Miss Weideman or Miss Alderson, there's going to be a lot of graphing in that class. And if you're looking at, I have to keep waking up my computer, if you check out the graphing that's going on in Miss Weideman and Miss Alderson's classes this year, that is going to directly impact what we're doing in here in the science classes, because as we put data points on graphs, we can tell if our hypothesis is confirmed or probably not true. And last little thing I'll say, remember, if you hear something, no, it's a scientific fact, that your ears should perk up, because there's no such thing really as a completely proven scientific fact. It's all a matter of probabilities, and that's what we're getting into this week with our very first experiment. So I've asked the students to go home and get their data from what we gathered here in class, which was the height of 10 people compared with their wingspan, or the distance from the edge of one finger to the edge of the other finger. In other words, how far can you reach out? In my particular case, my height, we did this quickly in class with our meter sticks, was 180 centimeters tall. Asked them to gather it in centimeters, not inches. And the distance from the end, one fingertip to the other fingertip, in my case, happened to be 177 centimeters in class. So try and get yourself 10 data points. We're going to use these in class tomorrow. We're going to graph them. And most importantly, we're going to use our interactive student notebooks to start gathering information and take us through this science journey that's going to take us all the way until June of 2022. Have a great day, everybody. Hope that was a good, quick overview of what class looked like the last couple of days. Look for the link to your Google Classroom that I'll mail on out. Take care. Bye-bye.